But the way we compare with other species, although we're quite different from them, there's only you're talking as if the difference is huge.
Well, it is huge
here. But is that what's being shown here? I mean, I'm seeing a few percent difference when it comes to the ampliconic.
You got to look at you got to look at the gene content, the size differences, we got to look at the whole picture. And when you consider overall gene content, size differences, and architecture, which also includes that heterochromatin and the palindrome sequences, that's where we find that overall the Y chromosomes are less than 30% the same.
And if you are talking about looking at the whole picture, then let's look at the whole picture. And the whole picture is that our DNA is 98%.
Okay, but Katz, in my presentation, I did show that paper from 2025, just a couple months ago, the sophisticated sequencing data of the great apes. And in the supplementary material, they noted that 12% of the human and chimpanzee genomes don't even align. What are your thoughts on that?
Align in terms of what? Basics, or when we're...
Yeah, like there's whole set, so gap differences. So you could take the chimpanzee genome and the human genome, and there's certain regions in the chimp genome that have no alignable counterpart to the human genome and vice versa. So there's sections that don't even align. So you basically have to discard them and say, well, okay, there's no way to align these, so we'll just compare the regions that do align.
But of course, you do know that if everything aligned perfectly and everything is the same, we would be the same species.
Right, but why 12%?
Well, if it was 11% or 11.5%, you could say why specifically 11%, 11.5%. You know, we obviously are different. Would you agree it's certainly more than 98% different? Think about it, if 12% of it doesn't align, how can you say it's 98% the same?